Okay, so for example 2, we're also going to use the three-part definition of continuity to determine if these piecewise functions are going to be continuous. So instead of having a graph here, we're just given the equations. So remember, for the first step, we have to figure out if it's defined. Now, we are working at x equals -2. So we need to figure out what f of -2 is going to be. Now, when you're using a piecewise function to figure out where it's defined, it's wherever it's equal to that. So see how it says x equals -2, so you're going to plug into this middle equation. So we're going to do 3 times -2 plus 2, which will give us -4. Okay, so we can say f of -2 is defined. Okay, then for step 2, we have to figure out if the limit exists for -2. So remember, we have to check the left and the right in behaviors. So I'm going to do the limit as x approaches -2 from the left. Okay, so from the left would be when x is less than -2. So we're going to use this top equation. And we're going to do plug in. So that will give us -4. And then we're going to do the right side of the limit. So for the right side of the limit, we're going to use the right side where it says x is greater than 2, or -2. We're going to use this bottom equation. Okay, so that's going to give us 1 e to the -2. You can just rewrite that as 1 over e squared. That's really all you can do to that. And then cosine of -2 pi. So if you remember from your unit circle, let me just draw a little unit circle over here. We have what's called coterminal angles. So if you were to do -2 pi and you wanted to make it on the unit circle, you would add an entire unit circle to it. So when you add that, you would get 0. So this is the same thing as saying cosine of 0. Well, we know that cosine of 0 is just 1. Okay, because that's the ordered pair, 1, 0. So this gives you 1 over e squared plus 1. So for the left side of the limit, we got -4. For the right side of the limit, we got 1 over e squared plus 1. Those are not the same. So we can say from this here that because these two things are not equal, okay, the limit as x approaches -2, f of x doesn't exist. Okay, so you just got to make sure you show and they're not equal so it doesn't exist. So remember, if that happens, you can stop because step 2 didn't work, and we can say, therefore, f of x is not continuous at x equals -2. Okay, so we made sure it was defined, but then when we did step 2 with the limits, the left and the right weren't the same, so it didn't exist. Okay, so our next one, same directions, we're using that 3-point definition of continuity, and we have this piecewise function here. So we're working at pi this time. So for step 1, we have to figure out if g of pi is defined. So using your piecewise function, you want to find the one that's equal to, which is here. So we're going to use the second one. So we're going to have e to the pi tangent of 3 pi over 4. Okay, so if we draw this little unit circle, 3 pi over 4 is in that second quadrant, and it's going to be that middle one. So in the middle, we know we always have the 2's, and we do have to worry about a negative, so the x value is going to be negative there. So when you do tangent, when you divide y divided by x, because these are the same thing, you would get -1. Okay, once again, because when you do y divided by x, if you do same change flip, everything will cancel except the -1. So we get -e to the pi power. So, because we have an answer, we know g of pi is defined. Alright, for the second step, we have to check the limit from the left and the right. So we're going to do the limit as x approaches pi from the left of g of x. For the left side, this would be when x is less than pi. So we're going to use this top equation. So we're going to e to the pi cosine of pi. Okay, so we're looking at pi, so if we add pi in on our unit circle over here, that's that order pair negative 1, 0. So we're going to have e to the pi, and cosine of pi is negative 1, so we're going to get negative e to the pi. So that's our left limit. So now we're going to do the limit as x approaches pi from the right. So because we're looking at when pi is greater than pi, we're going to use the second equation, so e to the pi tangent of 3 pi over 4. Now pay attention, you've already done this work here in this first part. Okay, we did the same thing, we got negative e to the pi. So make sure for your response to questions, a lot of times they repeat themselves. Okay, so the left and the right limit are equal. So because these two things are equal, I can say the limit as x approaches pi of g of x exists. So that means step 2 passes. So we can move on to step 3. So step 3, you're trying to see if step 1 and step 2 are equal. So in step 1, we found out that g of pi is negative e to the pi. In step 2, we found out the limit as x approaches pi from the left and the right both gave you negative e to the pi. So this means that g of pi is equal to the limit as x approaches pi of g of x, which is what we needed in step 3. So because all 3 parts are equal, now you can say g of x is continuous at x equals pi. Okay, because all 3 things pass, we can say that it is continuous there. Okay, so moving on to example 3. So example 3 is normally how part of a free response question with this stuff could look. So it says, consider the function f of x to the right. And so we have this piecewise function. It breaks in the graph at negative 1 and 3. And if you notice, we have some variables m and k here. They're probably going to ask us to find. So for part A, it says, what 2 limits must be equal in order for f of x to be continuous at x equals negative 1. Okay, so if you're thinking about that 3-part definition, the first part says that it has to be defined at x equals negative 1. So even though I didn't ask about that, I'm going to go ahead and make sure I write it. So f of negative 1, is that defined? Well, I don't really care what it is, but it says, is it defined? So because it has that equal to, that means it has to be defined. So it is defined. So just keep that in mind, that we have to make sure that works in order to do this. Okay, but the question really says what 2 limits must be equal. So think about this was step 1. In step 2, you always say the limit exists. So remember, for the limit to exist, the left and the right limits have to be equal. So we're saying the limit as x approaches negative 1 from the left of f of x must equal the limit as x approaches negative 1 from the right, and that's for f of x to be continuous at x equals negative 1. Okay. And because this is defined as the same place where it's less than, that will show you that the 2 limits are going to be equal. So step 3 in the 3-part continuity would be equal. Okay, so when we get to part B, what 2 limits must be equal in order for f of x to be continuous at x equals 3. So same kind of thing. First, let's make sure it's going to be defined at 3 so that this will actually work. So see how there's an equal to sign at 3. So this will work because f of 3 is defined. Okay, but when it says what limit, so the limit as x approaches 3 from the left must equal the limit as x approaches 3 from the right for f of x to be continuous at x equals 3. Okay, so then when we get to part C, part C says determine the values of m and k so that the function is continuous everywhere. So we're saying the only 2 places where it's possibly not continuous is at negative 1 and at 3. But we said as long as the limit for the left and the right for negative 1 are equal, and the left and the right limits for 3 are equal, that means that would be continuous at those spots. So we're trying to figure out this whole graph would be continuous if we make that happen. So for part C, I'm actually going to use part A to get there. So I'm going to draw an arrow for part C. We're going to go up here to part A. So we said that the limit as x approaches -1 from the left. Well, -1, left of -1 would just be 2. So this limit as x approaches -1 of f of x would be 2. And we're saying that must be equal to the right-sided limit. Okay, for your right-sided limit here, this is when x is greater than -1, in this category here, it says mx plus k. So for mx plus k, in order to find this limit here, you're going to use direct substitution, and x is going to be replaced with that -1. So this is going to be m times -1 plus k. So in order for this limit to be the same for the -1, this is the equation that has to be true. Okay, and then we'll come back to that. And then for part B, which you're still using for part C here, okay? We said the limit as x approaches 3 from the left. Well, 3 from the left, when x is less than 3, that happens at mx plus k. Well, same thing. We're going to do direct substitution. We're going to plug in the x value of 3. So m times 3 plus k. And that must equal the right-sided limit. And the right-sided limit when x is greater than or equal to 3 is at -2. So that's going to go here. So this is our other equation. Okay, so we have one equation at -1 to make that true, and one equation at 3. So now we're going to bring these two equations down to part C. So we have 2 equals, and here I'm just going to write -m plus k. And then down here, I'm going to write this in the same order. So see how it says equals -2, so I'm going to put -2 here, equals, this says 3m plus k. Okay, so what I've set up here is a system of equations. So these all line up, so we have our numbers, our m's, our k's. If I subtract these two k's right here, that means those would cancel. So I'm going to subtract each thing here. The purpose is to get those k's to cancel. So if I do 2 minus -2, that will give me 4, equals, and if I do -m minus 3m, that would give me -4. So now we can solve for m, and m will give us -1. So there's our m value. To get your k value, you're just going to plug it into one of these equations. So I'm going to take the top equation, I'm going to plug in m equals -1. So that means k would just give you 1. So if our m value is -1 and our k value is 1, that means that this entire graph would be continuous because we said that's where our left and our right limits would be the same at both of those numbers.